Everyone, what I want to do today is I want to kind of give you the tools and knowledge to represent more complex arithmetic and more complex mathematical expressions inside of C++. So say, for instance, if we were to have, say, an algebraic expression, and it doesn't have to be anything crazy, maybe for instance like this simple expression here, just to start with, we have x is equal to 3 times y over 2. Okay, pretty simple. Let's go ahead and get a program going. I'm going to use IOStream. Again, everything in this class is going to use IOStream. It's just in order for us to get input and output to the console. Alright, you guys, I'm not gonna lie, I never did get used to this keyboard, and it's been driving me crazy, but I gotta live with it. It's just way too compact, so, but don't worry, we'll make lemonade. Alright, so x, again, signed with 3, y over 2. Let's do this. So, first thing we'll need to do is, let's go ahead and make an integer. We'll call it x. We're going to turn around and we're going to say x is assigned with 3, and then times, and then we need y over 2, right? So now we need to add y. So x is assigned with 3 times y divided by 2. There we go. And you know, we can go ahead and we can ask the user cout, enter a value for y. We can enter in a value for y, and then we can go ahead and display here. We'll go ahead and put in 1 for y. So what's going to happen here? We have 3 times y, which we have is 3 times 1. We're going to go ahead and assign that to 3, and then we have 3 divided by 2, and we see 1. So what's actually happening here behind the scenes as well? Well, we have an integer, remember? And if we have an integer, it does not store the floating point precision. Let's quickly change this to double. Let's see if we get any different results. I'm going to go ahead and enter in 1 again. Now we see 1.5. Now that's what we were more expecting, because when we have 3 divided by 2, so we pull it in half, that is 1.5. It's not 1. So it wasn't that the expression was wrong, it was that the data type is not able to store that level of precision. So the idea behind typecasting is that when you have a variable that's been declared and it's being used as one type of data, so for instance, if you have an int and you've created an int, you can in a specific instance treat it like a double. So you can have the compiler recognize it as a double for an instance here. So what would that look like? Well, let's go ahead and make a real quick example. Say for instance if we had, and I'm going to take this example from the textbook so you can follow along for the full description. That would allow you to kind of dive in a little bit more deeper if you'd like to, and the example you can follow along with it. We're going to have a variable called books, and it's going to be an integer. And then we're going to have a variable called months, and that is going to be an integer as well. And then we're going to have a double. We're going to call that per month. And the idea behind this is we're going to make this program with a number of books to read the number of months that we're going to spend reading, and the average number of books that we'll need to read per month in order to hit all of the books that we put in within the month period. Okay, real quick input-output questions here. We're going to have a cout statement, and that's going to say, how many books do you plan to read? Okay, we're going to cin with a cin statement, books. Now we'll capture that input. Then we're going to have another cout statement, and this one here is going to ask, how many months will it take you to read them? Wow, there we go. cin months. Now we're going to have per month, and this is the equation that we need to have. We need to have per month, and then we have books divided by months. Okay. And we're going to say cout, that is per month is our variable name that we're going to have displayed. And then we're going to have books per month. We're going to go ahead and end the line, return 0. That is the entire program. So let's go ahead and run this. How many books do we plan to read? Let's say 5. How many months will it take you to read them? Let's say 6. That is 0 books per month. So what is wrong here? So let's check in our math real quick. So how many books do we plan to read? 5. Okay. Well, and just so that we can just easily do this real quick for the lay. Here we go. If you don't want to do the math, we have 5 books, and it's being divided by the months, which we have 5 divided by 6. So that's 0.83333 books per month. So we have an extra month here, because we could do 1 book per month, but we don't have to read an entire book. We only have to read 83% of that book, so to speak. So the answer is 0, and we know that that's not correct. It's not precise, and we have created a double to have that stored. But what's happening here? Well, the problem is that because these are integers here, we're not able to do this arithmetic here with between 2 integers and have this include precision. So what we're going to do is we're going to use typecasting, which is the topic that we've been talking about in Blackboard, and we're going to statically cast this expression here. We're going to do the entire expression with the static cast that's going to treat this like a double in this instance. They're still going to remain ints up here, so that way when we pull in the input, they're still treated as ints. Everything is still an int about it. This is going to change that on this line 15. So now what I'm going to do is I'm going to come in front of books, and I'm going to statically cast books as a double. To do that, I need to write the keyword static cast. I need to then put what it is that I'm trying to cast those into, which is a double, and then I need to wrap what it is that I'm going to cast as that double inside of parentheses, which in this case here is going to be books. And now that books has a level of precision that we can track, we could store that precision into per month, which can track that level of precision because it is a double. It accepts floating point values here. So we got this here. We're ready to rock. Let's go ahead and run this. And we're going to use 5 and 6 again as our input, which should be 8.333 repeating. There it is, 8.33333 repeating, and we're good to go. Now what if we only want to represent 2 levels of this precision? So if we want .83, what if we wanted to do that? So to do that, what we would need to do is we would probably need to use something from the I/O manipulation library, and that is include I/O manip, and this is a stream manipulator library, so we can change the stream at which things are output here, and that's what we're going to do. So in order to change the stream so that when this prints, it says, hey, only print out this here, this amount of precision, we can do that. Now this is perfect and key for currency. We're going to apply it to this situation here. So somewhere before this cout statement, I'm going to choose to just do it right above it on this line 18. Somewhere before it, we need to put a cout statement that is going to include set precision, and set precision is a function. And this function is going to take an integer as its argument, and that is the amount, the level of precision of whatever variable that you want to be set, and it's anything that's after it here, the thing that's immediately after it. This per month is what it's going to modify. We said we wanted 2 levels of precision, so we only want to see .83. We'll still have the 0, of course, 0.83. So we're going to go ahead and run this and see what we get. 5, 6, and there it is, .83. Now what happens if we change the data? And by that I mean, what if we go ahead and we say that we have quite a few months, but not enough for the amount of books that we have. So say we have 1 full year, and we're going to put that in the second part, and we have to read, let's see, 200 books, and we're going to read them in 12 months, and that's 17 books per each month, and that works perfectly fine. There we are. But you know, we may not have the level of precision that we're wanting to track. So to track that, what we can do is we can just go ahead and just check our results that they are indeed correct. And I'm going to go ahead and pull up this calculator, because we know that this is not going to divide completely evenly. So what is going on? So we're going to take 200 and we're going to divide it by this 12, and aha, here we go. We see that it's 16.6666 all the way down. So we know that it's not 17 books. So what's happening? Well, set precision is actually dictating this. It's showing you 2 levels of precision. 17 dot, that's the 2 levels of precision. So here's the problem. If you have set precision and you're only wanting to show 2 levels of precision, you need to have an additional keyword to specify if you want the left-handmost side to be of the decimal place, the left-handmost side to be tracking as levels of precision, or only the right-hand side. And if the answer is only the right-hand side, like we originally intended, we only wanted to see the level of precision being modified on the right-hand side of the decimal point, what we can do is we can insert another keyword called fixed. We can insert that into this output stream statement. And again, we only need to do this once, and then the thing after it will be modified. So it's just its own independent statement. We could have also included that in here, but it's a little clunky, so we'll leave it up there. So now let's run this program again, and I have that instance still up, so let me close that real quick. Here we go. How many books do you plan to read? 5 and 6 months. Again, there it is, 0.83 books per month, and we're good. Now, if we were to do that other example again, we had 200 books. We had 12 months to do that. Perfect. There we go. 16.67. Now, why does it change that? Because it was 16.6666 all the way down, and then 7 at the end, just as it's round up. So what's actually happening here is that set precision will round up. That last point of precision, if it's 5 or above, it will round that up to the next whole place. So in this case here, where 6 was the next digit after this here, it then rounded that up to 7. So that's what set precision's doing. Now, I want to make it very clear that this here is just modifying the stream of output that's here. It's not actually changing the value any way at all. This is just so that you can see it and see it in a formatted output. So this topic is underneath the formatted output. There's some other features inside of the IO manip library, and I encourage you to check those out. These are the ones that you're going to be using the most, so look out for those. The other one that you'll probably see is show point. And what show point does, I'm going to go ahead and put this in here. What show point does is it actually will display any trailing zeros. So say for instance, if our result was 5.00 like this, if this we were trying to represent, say if we were trying to represent $5 here, no matter what we did here, if we just printed this out like regular, it would just be 5 because of the trailing zeros. So with between set precision and show point, this will show trailing zeros. Set precision will, and if you have it especially fixed, this will also display trailing zeros as well. So this is not completely necessary, but I want you to know what it does is it simply will display trailing zeros. So it's up to you if you want to include it or not. If you have this configuration, this fixed and set precision with a level of 2, you probably don't need it because you have your bases covered. So it'd be an overlapping include. But those are the 3 stream output modifiers that you have for cout. So I wanted you to kind of have that as an example. And there's a lot of examples inside of the book that you can take a look at as well. Okay, in the next video here, I'm going to show you some of the C Math library functions.